Hello, welcome to another problem session. Today we have a very important problem that you should understand fully if you want to really understand angular momentum. This will help you use angular momentum properly. So this is a very simple system. It's called conical pendulum. You're probably familiar with pendulum, where it goes back and forth. Regular pendulum is plain pendulum. It just goes and back and forth in this thing. So this whole thing remains in one plane. So say this is XY plane. So the mass does not leave this plane. It stays, but this is the plane pendulum. But conical pendulum is different. Over here you can see the mass, the bob actually comes out of the plane and then back to the X plane, and then so you might say this part is kind of behind is behind the board here, right? So this is plane, this is plane, this is coming off front and go back there. So the reason it is called conical is because if you complete this shape here, it becomes like a surf. This thing is moving on the surface of this cone shape, but there's no cone there. It's just it's a string, and the shape of the surface on which M moves is a cone. Okay, so we're supposed to find angular momentum of this. And for concreteness, we say when it's at A, when it's at B, when it's at C, when it's at D, exactly opposite four corners, right? So if you say, okay, this is the four corners. Okay. All right. First thing to notice is definition from the definition of angular momentum of a particle. So if I wanted about O, will be R cross P, and P is just mv. So R is this is the radial vector from here to here is R. So the R is L, and this is the, if think of a spherical coordinates, that's the direction. Let's call it R hat. If it's over here, when it's at B, R hat will be that direction, and when it's over here, the R hat will be that direction. So this R hat at A, R hat at B, R hat at C, and back there it will be in that direction, R hat at D. So the length of that will be L. So the L is all fixed, and this R hat is A, B, C, or D, right? In the crosses, what is the momentum? Well, it's mass times velocity. So let's put that mass and a velocity vector when it's at A, B, C, or D. But what's the velocity vector? It's going to be speed times the direction, and it says speed is uniform. So this will just be speed times let's call it v hat for the unit vector. Hat, it means some v hat is unit vector. And I find it much more useful to think in terms of unit vector than just some other way of thinking about it. So if you're uncomfortable using unit vector, you may have to practice more and get used to unit vector. What is a unit vector? It's a way of telling direction. So if I have some direction I want to say that, say there's a, suppose I want to say momentum in that direction. Well, we can say, hey, let's have a unit vector p hat, and this magnitude is p. So the p is actually p times p hat. And when I use unit vector, it kind of helps me separate out the magnitude part from the direction part in an analytic way. It gives me analytic method. And because once I get analytic, I can do algebra and everything. So the whole thing just falls apart nicely. Okay. So ML, these all can be combined, MLV. So this is going to be the magnitude, and this going to be direction. So this will give me direction of L. And depending on which one of R it is, one of these, which one is the V it is, I'm going to get different directions. But the magnitude remains the same, right? So this calculation actually helps me separate out the magnitude. So we got the magnitude is same, but the vector will may be different. So how do I figure out cross product? So let's look at A. So at A, it's I'm going to just use this figure so it's nice. So this is A, and which way is the velocity actually coming out? So at that point, velocity vector is coming out. It's R direction. So I'm going to just do my right hand rule for that so you can see it. So I put to R direction, R hat direction, and I kind of rotate. So it's going to be that way. So this is so R hat cross V hat at A. Of course, it's going to be perpendicular to both R hat and V hat. Okay, and use the right hand rule. Use a right hand rule. And so when I do that, it turns out to be the direction turns out to be that direction, perpendicular to this, that direction. That's the direction for let's call that direction L hat, just to keep consistent with all my notation. So this is the L hat at A. Okay, so we got the direction for A. So as indicated there, that's the answer. Answer will be that direction when it's at A. But I need to give all the other direction. So this is the R hat A, and V is coming out. That's the V hat, and this is the L hat. So L hat is in the plane. L hat is in the plane. This is out of the plane, and this guy is, so this is 90 degrees. This is A, answer for A. Answer for B will be, so this is, now it's coming out of my, R hat of B is coming out of, coming out of the paper, but not towards me, coming out of the paper, but not towards me. And V is that direction. So we'll say V is that direction, V hat at B. So now I do this, and it's going to be, so R hat B cross V hat B is perpendicular to both R hat B and V hat B, so it's going to be perpendicular both of them, and it's going to come out, and it's going to when I do this, it's coming out in that direction. So it's kind of coming out. It has to be 90 degrees to that and 90 degrees to that. So this is the L hat at B. So it's actually this is in plane, parallel to the plane, but this is not parallel to the plane. So this is kind of coming out, and this thing is also coming out. And if I can make it B is just in the plane, and this is 90 degree and that's 90 degrees. Kind of hard to draw, right? So this is going to be answer for B. Answer for C will be so answer for C is a kind of interest. Answer for C is, this is the R hat of C, but then VSC is into, it's going away from us. So we can write down V of C is like that, V hat of C. So this is in the plane and this is out of plane 90 degrees. And so when we do this, it's I need to do hand this, and so it's going to be that way. So L hat at C is that way, and it's in the plane. So I shouldn't have drawn thick. Should have drawn just regular. So in the plane, but 90 degrees, and this 90 degrees out of plane. So D, I'll let you do D yourself. So if I draw out the pendulum, and this is going in this circle, and I draw L over here. So you can draw when it's over here, L is that way. When it's over here, L is that, this is 90 degrees, and L is that way. And you can see, so this is A, and this is A, L direction. So L kind of rotates around like that. The L rotates as A goes from B to C. So L is over A, over C, over here is a B, back there is a D. So it kind of rotates like that. So let me recap. First of all, this is a very important problem for you to master and understand, because it is a complicated concept of how to use a cross product, how to set it up. I have one way of setting it up, and you may have other ways of setting it up. So whatever works for you in terms of cross product, you should use it. So important part of the cross product, I was able to boil it down to this, and you have to notice that they are perpendicular to whatever come out is perpendicular to both of the things you're cross producting, and you can use right hand rule to actually get the direction. Sometimes right hand rule is a very hard thing because you have hand can only go so much, so you can use the left hand and then flip the direction, right? So if you use right hand rule and it's like too twisty and you're not getting right sense of the whole thing, then you can use the left hand rule if it works better, and then you get whatever direction you get for the left hand rule, and then actual thing will be just flipped over. Okay, that should be it. I'm gonna stop here and talk to you later in another video. Bye.